I'm live. Okay, where was I here? I'm a little out of it today, but we're going to try and make progress. Yeah, that's the one. So we're going to replace the movement component with our movement component. Sorry. I'm slowly dying over here. Okay, so we're going to come up here. This is going to change now. Now we have the const initializer. This would be this super set default u ag character movement component. A character movement. Ooh, excuse me. That also means that this needs to be updated. Oh. Oh, this is the wrong one. My bad. There we go. There we go. I have it all set up. I can see everything now. What's changing here? All right. Yeah, there. What's going on? No overload. To do. Why is it not working? Character. Would I just be able to move this into here? Maybe this. Oh wait, this is gonna require delete of this. Cannot convert. Hmm. Okay, let's try this here. See what our error is. No overload function. Oh, I see. Damn it. I have to do this for all of them. Oh, that's so much fun. I'm being very facetious. It's not fun. Ugh. Come on. There we go. Um drill. Good. There we go. On that note, I'll be right back. I have to go check my laundry. My dryer is still going. It's updating, but it's not running properly. I think this is probably the problem here. And I'm not sure. I can close this one. We already did that. I think here we're not running in. Yeah, we're not. We need to run in debug. Okay. Then we hit play. Huh. If movement. Oh, right. We want this. We're hitting this. And our movement is not. Our movement mode is not set. Huh. So it's not actually updating it. Where's our task? Let's do this. Okay, we step over. We step over. What's our new movement mode? Sprint. That's the movement mode component. This. Move custom. Here, move custom. Where's our character? Our character's missing. It's been thrown away apparently. Where's character? Character's not here. There's the character movement, but where's this? Is this because of because it's const? What if we do this? Let's try this. Okay. This is doing something weird. Not that. A character, that's what it was. Uh, ugh. Okay, so we are currently here, right, on line 23. Then we step over and we jump down to here. We don't even execute this. Like, this doesn't even get executed, which is a problem because it should be getting executed. Okay, so in this situation, how do we even call this? Right? Because, like, if we're here, how does this get called? Let's step into it. Fuck, you gotta be kidding me. Okay. God damn it. I don't want to step into the disassembler. And of course it's stepping in. God damn it. God damn it. I don't want to step into the disassembler. Ooh, excuse me. So it's never actually updating that at all. What the is going on here? This never gets executed. So how can okay get what if I do this? There we go. Ugh. Okay, so what we're gonna do, I'm gonna come into here. I'm gonna make a quick change here. Log the current movement mode. I don't think that's it. It's not changing the movement mode. Sup, running bird? Galaxy Unpacked. I don't understand it. Ugh. Okay, so this is happening. Let's also get the let's log this. Get current movement mode. Get character name. Okay. Screen debug. F color. Cyan. Wait, I need to relaunch this. I don't actually want that. Because we already know that it's not quite working. So because it's an async task, it's not working properly. Yay! Okay, so it is custom. Oh, wait, is it because I'm not committing it? I think we need to like commit things and then uncommit things, and that's probably what it is. But I think that we can do that in here. Yeah, commit. Wonder if that's what the issue is. So we are seeing it change, right? So if I change this here, we're going to do that. And we're going to do that and save compile. Now this is going to... Oh, right. I need to make a quick change here. Oh, wait. I know what we're going to do. Custom. That's fine. What we want to do here is we want to say if there, but we want to change this to walking. And this should be custom. So then if we do this and we come into here, move this over here, save, compile, save all, close this down. Hit play again. I'm going to open the ones that we just closed, hit play, walking. Now, I don't think we're getting this message anymore. Yeah. This is kind of the problem, though. Okay, let's hit play. There's the walking. And now it stops updating altogether. Starts. Oh, that's interesting. Because it failed. Apparently it failed. False. Oh, that's why. True. This also is a problem here, because essentially we don't have enough of these. So why is this not updating? It's saying that it's updating. It's like, hey, I updated. We committed. Can we please move forward? Yeah, it's still walking. Hmm. So what's the issue here? Okay. Value equals true. We commit the ability. But I still don't know what our movement is. Because I don't really have access to it here, do I? Would this be like, what if we do this? Okay, so avatar character, update character movement. Update. Update the love it. Unreal Engine update character movement mode. Am I using a set for this? Maybe that's what I... No, there's the set movement mode. There's the set movement mode right there. And I don't think I'm overriding it. No, just max speed. There's the custom. Oh, wait. This isn't the right set movement mode. What was it? Is it F? Is it E? No. Let's try this. Okay, let's make sure everything's saved. Save all. And then we're just going to rebuild. Where's our... There's the RPG. There's this one. See here, we can see that it's walking. See a little bit here. There we go. What's the problem here? Oh, right, because this doesn't have the %s. Here we go. Hmm. This is just being annoying. Save. Let's try this. Cleric a character. Get name. Not path name. Get display name. Print. Fuck. I need to make some changes here. This does not need to be here. There. Need to save all. Close that. I'm just gonna rerun this. I forgot to even check what my name was. I forgot to change my fucking thing to character movement. Oh well. I'm just gonna do this. I'm gonna go over to here and we're gonna change this. Edit. Update all. There we go. If I refresh this, it should change, right? Yeah, there we go. Oh, beautiful. Did it finish starting? Yes. Open. Okay, now if I hit play, I should see... That's the player state. That's this is the player state. What about this one? Okay, so it's the avatar actor. What about this one? Oh, that's even better. This one's perfect here. Get. Wait, is that better? One sec. Yeah, it's an A player character. I think this one's actually the best. Okay, so that's a player character. What's the type of this? It's just an actor, right? Cast a character. Okay, so we're still casting properly. Good. There we go. Cool, 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 cool. We're there. That's good. Um, set movement. So this is the movement component. Get modified max speed. Wait, am I doing something wrong? This is the movement mode, right? Returns the pawn that owns. Character. There it is. That's the one I was looking for right there. I'm fairly certain this is the one that I was looking for. We're just going to bring that up here, go like this. I don't care about that. Get name. We're going to bring that down. And we're going to do this. Save, compile. Hit play. Okay, I think that's right. And we can come down here and we can do this. And we can say new custom. Save, compile. There we go. It's custom. Now if we go here and we say get movement mode to string, go like that. We can remove that. Save, compile. Hit play. There we go. So we have that, right? And then if we do get max speed, build string, oh, string patent. Sup. No, it was. Hydrate. How's the Power World server going, Lucifer? Format? Format text, that's what it was. Oof. Wish I had someone to play with. I'm clueless. I know the feeling. And it's not working. It's like, it's straight up just, nope, we don't want to work. Just make it work. I'm trying. I'm trying here. I don't know why the Okay, so what we could do, I'm just going to try this to see if it will work, right? So we get this. So I'm going to do, we've got 2 here, right? So if I do this, come into characters, player character, open up the player character, come down here, we've got walk speed 800. And 2. Beautiful. Okay, so now what we can do here is on this press, we're just going to multiply it, right? So we'll say set max walk speed. To it's totally not what I wanted there. Float to float. This looks like a mess because it is a mess, but that's okay because I don't need it to be perfect right now. Okay, so that does work, right? But why does this not work with the custom movement mode? This looks like a mess because it's a mess. Yep. Don't worry, I'm gonna clean it up, but yeah. But not custom. When I set the movement mode to custom as shown in the begin play, the character doesn't move. I believe your character movement mode has to be set to flying in order to move the character on the x-axis. If you keep using custom movement mode, you'll want to use launch character. You can't use... That's not what I want. Why no Windows 11? Because I don't actually have a desire to use Windows 11. I will use Windows 11 when they force me to move. I will use it in March of next year. Sorry, October of next year is when I'll start switching over. Windows 11 is still too early days for me. When's Windows 11 end of life? Wait. Windows 11 is going to be end of life in October of this year? Oh no, that's just... Okay, never mind. Yeah, I'll just not be moving to Win. I'm hoping by the time I get around to upgrading to upgrading to Windows 11, I can just switch over to Linux. I'm not gonna lie. I would rather be on Linux than Windows 11 fucking upgrade. To be fair, I'm not a big fan of Windows, so that's probably where a lot of that comes from. There's already a Windows 12. Like Windows 12, didn't they already announce it? I thought they already. I just love how short Windows 10 was around. Like they're like Windows 10 will be the last version of Windows that we release. Windows 11. After what, 5 years or something like that? Like Windows 10 wasn't actually around very long before Windows 11 came out. Is that what it's going to be? I could see that. Yeah, no, it's all stupid, to be honest. Well, no, because Windows 11 is a Windows version. They went back on their promise. They're like Windows 10 will be the last version of Windows, and it was just like okay. And now it's Windows 11 6 years later, and it was just like wow, you kept that for all of 6 years. Like I do understand why they did it. No, because Windows 10 is still Windows 10, right? It's still Windows. Windows 12, they're going to change the name potentially. So if that's the case, right? They'd have to change the name of the operating system to get away with that. Do watch this not actually give us a custom movement mode. There's this guy.
Hi
This
everyone,
guy's pretty
this is the
good.
start to a series I'll be making on the character movement component. In this video, I'm going to cover what the character movement component is and why you might need to use it.
Every OS got a major release per year. The only thing Microsoft did different was that they didn't actually change the version number. So Windows 11 is still using Windows NT10, which I think is hilarious. Like, so the reason why they switched from it being Windows 10 to Windows 11 was really because they wanted to do that hardware thing. I think they wanted to do that and they wanted to change the UI. And I think those are the two primary reasons why they did it. But the fact that they broke backwards compatibility in some senses, and it's been a buggy. Windows 11 has been a buggy mess, in my opinion. So far from what I've seen from Windows 11, it hasn't beat. There's no compelling reason to upgrade. Well, I get that they've probably ironed out a lot of the problems, but there's no compelling reason to upgrade. And like they really 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 tried to force it on people. I have to upgrade my stream PC because my stream PC doesn't support Windows 11, even though I built it last year. I can, I could see that you could probably, Outer Turtle, welcome. Sorry, I missed your message there. Yeah, no, I don't know. For anybody who's wondering, I've got both YouTube and Twitch going, so. Loads of little things, I suppose. I need to figure out the custom thing. So what I really wanted to do was like a custom thing. The new settings app is actually usable Explorer and Notepad and similar apps. Got updated so they have tabs, dark mode. You get pseudo. Do you get pseudo though?
All right, so welcome to the third video in the series where we're going to be uncovering in depth the character movement component in Unreal Engine. So in this video, we're finally getting into the code. So we're going to start by creating a new project in Unreal Engine, and I'm running 5.03. So yeah, I'm going to just wanted to interject here and say that it doesn't actually matter if your game is first person or third person, because all this is going to work the same exact way. And I'm probably actually in the future going to make this game compatible third person and first person. And also the link to all the code we're about to write is going to be in the description on GitHub. All right, and so now we have the default third person template loaded up. I'm just going to update the project file. And actually, before I do anything else, I'm not going to close out of this now that I created the project. And I'm going to go to where that project. All right, so now that that's loaded up, we can get to work creating our character movement component. So the first thing we're going to do is we're just going to create a new class called the Sippy character movement component. And I'm going to be pasting in code here because it's going to be too slow to type it all out. So first, responding constructor, and we're just going to leave this as empty for now. And then through the complicated and so now snapshot of all of the state data in the movement component that's required to produce a move for a single frame. So the end of this video is going to be about is just setting all that up. So now there's two helper classes that we also need to create. And so the first one is called saved move. And if you didn't watch the last video, I definitely recommend that you do that to get a good understanding of what we're actually doing here. But so a saved move is essentially a snapshot of all of the state data in the movement component that's required to produce a move for a single frame. So the character movement component is saving these saved move classes for every single frame of movement, and then it's replicating a minimal version of that to the server so that the server can perform the same exact saved move.
This is why it's not working. Wait, this guy's video seems really good so far.
Okay, so welcome back to the next video in the series where we're going to be going in depth on the character movement component. And so before we dive into the code, I wanted to do one more episode just covering the architecture of the character movement component because it's a pretty intricate class, and you definitely really need to just understand how it works just at a high level to be able to start writing your own custom movement. And so yeah, I want to just cover this first before we jump into actually starting to code some of our own custom character movement. Okay, so to quickly recap what the character movement component does, it's an actor component on the character which kind of has sole authority over the position of the character, and it takes in input vectors and events, like basically any keyboard events that you would use to control the character, and it turns these into updates to the character's position and rotation. And it does this through different modes. So the character can be walking, swimming, flying, or any custom modes that you would make. And each of these will determine what happens to these inputs and how it affects the outputs. So to jump in, so there are three network cases that you need to understand, and this is true for any replicated object in the game. And you're going to really need to understand this principle because this is why we need the character movement component. This is why it's so powerful, is because it handles the networking for us. So for any one player in the game, there exists three copies of that same character, one on the owning client, one on the server, and then one for every remote client that is just viewing that character but not controlling them.
Super true.
So the owning client will be the one that actually gets input, and it will perform moves, and then it will send data to the server to be verified, and then it'll get corrected by the server. The server will receive client data, and it'll perform moves with the client data, and it'll just send those to the other clients, and it'll potentially correct the owning client if needed. And then the remote client will just simply receive state data from the server, and then just interpolate those positions and rotations. But for our case, we don't need to care about the remote client because this is completely handled by the character movement component, and this is just a really nice feature because you just only need to concern yourself with the owning client and the relationship with that in the server. And so just for the future in this video, whenever I say client, I only mean the owning client of that character. So moving on, real quick, I want to just go over client-side prediction because this is essentially the main feature of the character movement component. This is why you're using this instead of like your own custom movement solution. And yeah, this is kind of the fundamental feature of the character movement component. So this is a network graph. And so on the vertical axis here, we have time, and I represent them in ticks. But you can think of like each tick as say 10 milliseconds. So like, you know, this is 50 milliseconds, this is 100 milliseconds. And
ticks are not done they're so much faster than that.
so on the left here we have the client,
or at least
the
they can
server,
be.
and these are the client and server's view of the position of the character. So at time zero, at tick zero, they both start at 0, 0, and this is without client side prediction. And then the client has this move that they want to do. They want to move forward by 1. Maybe they press W on the keyboard. So it sends the state to the server. But you notice this line is diagonal, and that's because the client has non-zero latency or ping. And so then at tick 5, the server gets this move request and it applies it to the position, right? But notice the character still hasn't gotten updated yet because they don't have authority over the position of their actor. So then the server will send the client the new updated position that they should be at. And then at tick 10, the character says, okay, now we're going to move to this position. So that was 10 ticks or 100 milliseconds delay between the client, like say pressing W on their keyboard and actually seeing their movement of their character. And obviously this is just unacceptable. Like, you can't have this input latency because your game will feel, really laggy. And, there's pretty much no modern day video games out there that have this kind of system, this old system with input latency. So how do we do it the right way? And that would be with the client side prediction. So here we do the same thing. We send this move request to the server, but we also immediately apply the move on the client. And we apply it as a prediction. So we're not this isn't the authority because the server's still at 0, 0. So this is just a predicted value that we're moving on the client. And our hope is that this will line up with what happens when the server actually applies the move. So you can see it's at this new value. Immediately, the server applies the move, sends back the corrected position, and success. These positions are the same, so we don't need to worry about it. The client successfully predicted the move that the server would make with its request. And so as a result of this, you can see here, this is like kind of how it would look if you're controlling this 2D character. You can see the result is that the client is actually ahead in time. So they're in the future sort of from the server. And so here you can see maybe the client was sending moves every single tick. And these moves, these intermittent states, are all pending moves which haven't yet been confirmed by the server. And so when the server gets one of these moves and it sends back the position and everything worked out, this is called acknowledge.
It also throws them away. It'll like, so like, let's say that we've got 20 and or whatever, T16. I don't know why it's going backwards. Oh wait, yeah, because tick 20 on the client, tick 15 on the, if we've got a 5 difference, right? So like we're sending these all, but these could come in out of order because there's no ordering, right? Because you traditionally use UDP. So these could come in out of order. And then if they do come in out of order, right, you want to have like different things. Anyway, so interesting. My bitrate's too high for Twitch. Yeah, I'll have to adjust that later.
Acknowledging the move. So the server will ignore.
Yeah, so it will throw them away. So like, let's say that it gets 17 before it gets 16, it will throw 16 away because it's irrelevant.
The client's moves. So how does this work in Unreal Engine specifically? So every time the character makes a move, this is called a saved move. And basically, the client will save all of the state data that was required to reproduce that exact same move. And it'll send a compressed sort of version of that to the server so that the server can recreate that exact same move. And then it'll keep advancing in the future. And then this position, tick 15, was the last acknowledged move. And so this saved move contains all the data required to replicate a move at any time. And so importantly, the timestamp is sort of the identification of the ID of a move. So a move is recognized by its timestamp. Instead of ticks here, the timestamp is kind of what defines a move. Oh, and so also an important note is that in order for this to work, in order for the client to like successfully predict that the move that the server will do, and for them to line up, the function, which the server and client call the same move function, the idea is that the function needs to be called with the same exact data, and the function needs to be completely deterministic. So you can't have any like random numbers in there, you can't have any outside state data. So you can imagine like if the move function called a random vector, and then the client was moved in that random vector, then the client will perform the move, but the server will get a different random vector, and their moves won't line up. They won't end up in the same place, and this will cause the server to have to correct the client, and the prediction will fail. And so that's just an important thing is that the functions need to be completely deterministic, and they need to operate on identical input parameters. And that's going to be the thing that you really have to get right in your character movement component. So now we're going to look at the client pipeline. So this is just the path that the client takes for each move. So it all starts with the tick component, which makes sense because the character has to move every single frame. So the tick component will simply consume the latest input vectors, which basically just means all the key presses that the client pressed in that frame. It'll then take those inputs and it'll send them to the controlled character move function. And all this function really does is it takes those vectors and it applies it to the acceleration. And this is just kind of a mundane detail. You don't need to worry about this, but this is sort of the main junction. So the control character move will then call perform move, and perform move is where everything happens. This is the function that actually applies movement to the character's root component. And so on its own, perform move will just do things like apply forces and impulses, and it'll update the root motion. It'll also do stuff like if you triggered any character launches, that'll happen here. But then it'll call start new physics, which this will be this will be what moves the character based on the different movement modes. So this is where you will introduce your own custom movement modes, and basically each movement, each perform move will be different based on what the current movement mode is. So the movement mode is the big controller of how the character will move per each perform move. So we'll talk more on this later. But so after this chain has happened, after the move has been performed, again, this is the only client, so we have to send this to the server. So after this, we'll get this delta time acceleration, and we'll get the outcome of our move, and we'll call replicate move to server. And so the important thing here is we'll build a saved move from the outcome, from the inputs of the move and the outputs of the move. And we'll send sort of a minimalist version, sort of a compressed version, which is this F character network move data structure. We'll send that to the server. So this is a server RPC, and we'll call server move with this representation of how we just moved. And then the server will run this client move, and it'll hopefully get the same results that we got here in the client. So one of the nice features of the character movement component is that we don't need to care about this path really. So this path is pretty much completely handled. If we set up our save move correctly, this replication path will all be handled under the hood. And we really only need to focus on the actual movement logic, which is what we care about, right? And we really just need to focus on the start new physics because there we're going to be running our own custom physics functions. So really it's just this guy that we need to give our attention to, but you do need to understand how we get there and what goes on to get this all synced up on the server. So moving on, we'll talk about how the server pipeline works when the server handles the moves. So this function, as we got from the last function here, this is where we left off on. So the server move will be called from the client as an RPC, and it'll first prep the state for the incoming move. So everything in that saved move that we sent to the server, it'll have to prep the server so that it's operating on the same exact input parameters that the client was operating on. Again, that's really important so that we get the same outcome, that we operate on the same inputs. So after it does that, and it does more prep here in move autonomous, and after it completely preps the state, it simply just calls perform move, just like the client did, and hopefully we get the same results. Then it'll call this server move handle client error. So one thing I didn't mention was that the client will also send.
prep state. Always handle client error.
And the results that it got after it called perform move. So now not only do we have the input state that the client operated on, but we also have the output state the client thinks it got, or the client predicted. And so then we'll check in this function, we will check, do those two output states match? Does what the server get and what the client get, are those the same? And if they're not, then we're going to have to do a client adjust position. And this is basically where we tell the client, okay, you messed up, your prediction was incorrect, and we're going to send you the real state, the authoritative state, because obviously everything has to be have server authority. And so the server is going to send this adjust position, and then this is going to run on the client, and it's going to reset the character to the server state, and it's going to resync with these pending moves, which we're going to talk about later. But so now what I want to get into is just exactly how this physics function works, because again, this is where we're going to be writing the meat of our code for how we want to create custom movement modes. So running from the top, when start new physics is called, and for lack of a better way of explaining it, basically this is basically how the code works. It's just a switch statement, and depending on which movement mode we're in, we're going to call it different physics function. So Unreal provides you with a couple default movement modes, and this is for if you don't really want to have advanced movement, or it also just serves as a good example of how to set up your own movement modes. And again, each of these modes has a respective physics function that will use the input parameters differently to calculate movement. But then where we come in is it'll also have a custom mode, and then we're going to define our own custom movement mode, which will have another switch statement on. And here we can define custom movement modes, which have their own custom physics functions, which run our logic that moves the character in our ways. And yeah, so this is where basically, it's been a long.
So this is the step that I missed. I didn't have a custom physics thing, right? So we're gonna get into that.
But this is where everything actually happens. So to get into the physics functions, so every physics function, you can treat it like a black box for now. It'll take in several things. It'll take in delta time, which is the crucial thing, because you're operating. Each movement will operate over a delta time. It'll increment the player by a certain distance based on the delta time we're simulating over, right? And also taking things like acceleration, which again is essentially just your input vector, other state data, like say if you trigger a dash or something like that, and then compressed fags, which is also just state data. So you don't need to worry about this for now, but just these are all the things that the physics function operates on. And then it will change the location, the rotation, the velocity, and then any additional state data on the character movement component. And this can be things like maybe it updates a dash cooldown, or maybe it flips a flag that affects whether or not you can dash, stuff like that. And so then there's also some helper functions that Unreal Engine provides, which you don't have to worry about this for now, but this is just useful. Like you can use some of these functions, which
what is this? No. I want to see who this person is.
will provide some kind of pre-built logic that you might want to use, such as, if you collide with an object while moving your character, then you're going to want to call handle impact, because that will do some stuff behind the scenes for you. Calc velocity is another good one. This will automatically take your acceleration and apply it to the velocity, which if you don't call this, you'll have to do this manually, but this will do that, as well as a bunch of other just handy behind the scenes stuff. And then before we move on, so the delta time is coming from the tick component, right? But this is frame rate dependent.
Is so slow.
This is kind of a problem, right? Because one, your frame rate.
Hey, Lucifer, don't worry, it will get better. I increased your leveling speed, resource gathering, PAL catch time percentages. So life should be easier. I even made it easier to build things.
Rate isn't going to be very fast. Like you might have a 60 FPS, or maybe at max you have 120 FPS. But this will provide a relatively large delta time. And also, this delta time won't be the same for different clients, for the server, just for all the different machines that are running the same game. So what we can do, since we have powerful computers, is we're going to split up this delta time into smaller simulation time steps. And this is called substepping. And then we can call this, we can essentially have a while loop or a for loop that is substepping over smaller sequences of the delta time inside of a singular physics function. But importantly, we could potentially change movement modes in the middle of a simulation. For example, say the character is walking, and in the middle of this simulation, they cross into a water volume, and now they need to start swimming. Well, what we can do is, halfway through this physics function, we can actually call start new physics, and this is the actual signature for the function. And we will give it the remaining time that will be like, say, half of the original delta time, and then we'll also increment the iterations. And this allows us to do, just this really fine substepping, and gives us a much more accurate simulation. And then for the remainder of the delta time, we will simulate the swimming physics mode, and we'll also increment iterations. This just keeps track of how many start new physics calls we made, and that way, say you potentially have some infinite loop where you're kind of stuck on the border between a water volume and like land, and then this might be, this might trigger an infinite loop. So there's just a max number of iterations that you can go to before it just prematurely ends the simulation. So yeah, don't worry too much about this, because this will be the bulk of subsequent tutorials. We'll be working on coding our own physics functions. So now we need to talk about client adjust position. So again, for client-side prediction to work, there's really two things need to happen. The client needs to predict the movement, but also if the client messes up, they need to correct the movement. And how this works is that the server will send this big kind of envelope that will contain all the data they need to correct, for the client to correct their state to match the server. And again, this timestamp will identify which move was off. So they'll say, okay, at 12.5 seconds, these are in seconds by the way, the timestamp or the move at 12.5 seconds was wrong, and you need to use this position and this velocity as well as some other stuff. And this is the correct state. And so again, the client has all these pending saved moves, which haven't been acknowledged. You can see the last saved move was actually at 14 seconds. This is an exaggeration. It wouldn't be this big of a difference, but the client has all these pending moves. So first what will happen is it will apply the server state just directly to the character, but then it'll loop through all the not yet acknowledged moves, and it will reapply them. And so this might be confusing at first, but I'm going to go here and show you. So say that we didn't have the system. Say every time the client was corrected by the server, it would just snap back to the server's position. We can see, so at this time.
Okay, so
move. And as you can guess, whether or not we want to sprint will have to be saved in our saved move.
So this will be our F save move character thing that we're gonna have to do. I'm just gonna move this over to the side here so we can take a look at it while we do this, because we need to update our character movement component. Fun. Would be that. Okay, and then this would be type def of F saved. We make a character AG. I feel like F saved. It should just be this, right? Let me take a look, because we've got a bunch of stuff in the gas shooter new window. And their movement can... Okay, so yeah, they've got the F saved move. So this is just F saved moved. F save move AG, because we want to inherit. That makes sense. Super. Wait. Huh, this one's different. Oh no, it's the same. Okay. I'm slowly going insane. Okay, so this would be character. And then we do the super. So this resets all the values. Saved variables. Why am I... There we go. Store input commands in the rest flags. Can combine with. This is used to check whether or not two moves can be combined into one. Basically, you just check to make sure that the saved variables are the same. Is that something that the other guy's doing too? Yeah, can combine with. Okay, so we just need to essentially bring over all of this. So we just do this, and then we come over here and we paste that in. I don't really like this brief stuff. We don't need that, so I'm just gonna go like that. Oops. These are our custom stuffed things here. Saved request to start sprinting. So we'll come back to this once we know a little bit more. Let's see. Let's just read through this though. Set up the move before sending it to the server. That makes sense. Set variables on character movement component before making a predictive correction. This is used to check whether or not two moves can be combined into one. Basically, you get to check to make sure that a saved variable, if the saved variables are the same. Check whether or not two moves can be combined into one. Basically, you just check to make sure that the saved variables are the same. I think that makes sense. Wait, this is my code.
Move because this variable is important to how the movement logic is executed. So we're gonna have to override the default class with our own custom, and all we're gonna add here is just a single variable that is going to be saved b wants to sprint. And so again, the difference between these, this is our working variable. This is the variable we'll be setting and checking and applying the logic based on the value of this. This variable will automatically sort of be updated to the current value of this variable every time you create a new saved move, and then every time you need to play a saved move, this variable will be copied into this one. And so we'll see that kind of how that plays out as we implement these functions. So I'm gonna go ahead and generate definitions for all these, and we'll go through these one by one. So can combine with is a function that basically checks two moves, the current move and the new move, and it checks can we combine these two moves. And the reason it does this is to save bandwidth. So the idea behind this method is that if all of the data in a saved move is pretty much identical, based on whether you determine it's identical, then we're going to return true, and that means that we don't need to send two moves, but we can just tell the server that basically run this move twice, or however many combined moves we create. That we don't need this variable frame component so that we won't get any rubber band or anything like that. Saved move. And if you didn't watch the last video, I definitely recommend that you do that to get a good understanding of what we're actually doing here. But so a saved move is essentially a snapshot of all of the state move classes for every. And as you can guess, whether or not we want to sprint will have to be saved in our saved move because this variable is important to how the movement logic is executed. So we're gonna have to override the default class with our own custom.
Wait, do we have that now? No, we don't. Okay. Yeah, we deleted that. Okay, let's make sure that this is all saved all. Save. We can close this and then we're just gonna stop it. There we go. So if we look at the other ones, we've got the U8 saved request to start sprinting equals 1, right? And if we go back to here, saved B wants to sprint. Same kind of idea, right? So I guess we do actually end up needing that. So this would be the U8 sprint. And this would be saved request to start sprinting. 1.
And all we're going to add here is just a single variable that is going to be saved b wants to sprint. And so again, the difference between these, this is our working variable. This is the variable we'll be setting and checking and applying the logic based on the value of this. This variable will automatically sort of be updated to the current value of this variable every time you create a new saved move, and then every time you need to play a saved move, this variable will be copied into this one. And so we'll see that kind of how that plays out as we implement these.
Okay. So here I would have bool
these functions. So I'm going to go ahead and generate definitions for all these. And
sure. Okay. There we go.
we'll go through these one by one. So can combine with is a function that basically checks two moves, the current move and the new move, and it checks can we combine these two moves. And the reason it does this is to save bandwidth. So the idea behind this method is that if all of the data in a saved move is pretty much identical, based on whether you determine it's identical, then we're going to return true, and that means that we don't need to send two moves, but we can just tell the server that basically run this move twice, or
Okay.
however many combined moves we create. So what that means for us is something like this. So first we're going to cast the new move to our custom class, the zippy save move. And then we're just going to check if the saved wants to sprint in this save move is not equal to the saved wants to sprint in the new move. So if these aren't equal, then clearly these two moves are not the exact same and they can't be combined. So we're going to return false. But if these two values are the same, then we're going to let the super handle whether they can be combined or not, because there's actually a lot more data in the saved move that's in the default class. And you can...
One sec, I want to see this. Can combine with. He's essentially doing the same thing. Save request to sprint is not equal to f save move get save request to sprint starting. Return false. And then they've got their aim down sites. We're not doing that right now. We might do that in the future. I don't actually know. I don't think so though, because like we're gonna pretty much have like right click is one right click is one ability and left click is another ability, right? Like maybe left click is your machine gun and right click is your rockets or something like that. Don't really know yet.
Peek in here and see that it has some parameters like force no combine. It checks that the accelerations are different. There's just a lot of other stuff going on here. So there's a lot more reasons why you might not be able to combine a move. But certainly, if the sprint values are different, you obviously can't combine it. So moving on to clear. Clear is the easiest one. All it does is just kind of reset a save move class to, or reset a save move object to just kind of be emptied. So for us, we're just going to do that and just kind of reset this flag. So now let's talk about compressed flag.
Okay, so here we're essentially just going to be clear. We also want saved plus to sprint equals 0. Right? Yeah. Let's see this. This one's... Can we do that? It does make sense because it's a BU8 and yeah. All right. Yeah, that works.
So compressed flags are actually the way that the client will replicate movement data. So the save move, as you can see, if I hop into the default character save move, there's a ton of variables in here, and it would obviously be way too expensive to replicate all of this to the server every time we perform a move, which is every single frame. So instead, we send a very minimalistic version of this, which, besides a couple things like the character handles, basically we just send these compressed flags. And the compressed flags are, you get basically 8 of them because it's a 8-bit integer. And you can basically do anything you want with these compressed flags, but typically, each flag kind of stands for some Boolean value that would most likely probably be tied to a key press. So if we actually look at the default value, we say, okay, if press jump, then we're gonna flip the jump flag. If wants to crouch, then we're gonna flip the crouch flag, and it just returns after that. And then we can add what we want. So ours is gonna look like this. And so all we're doing is we're first letting the super run, and then we're going to flip custom flag 0 if the character wants to sprint. So
that makes sense.
Basically, the sprint channel is going to be assigned to custom flag 0. And if we look at this enum here, what we'll see is we'll see those 2 flags we just saw for jumping and crouching, and then there's 2 reserve flags.
Okay, let's take a look at the get. Yeah, this makes sense. There's our custom 0, custom 1. This is going to be... This makes sense. This makes a lot of sense. There. So all we want to do... Where's ours? That's the task. We can close out the task. We don't care about the task right now. Don't care about that. We just care about this one. Here, and if we do the compressed, this is the compressed one, we get this. What does this return again? No, this is a uint. Uint 8. Result equals, and return result.
That the engine kind of wants movement for like one essential time. So yeah, that's what the compressed flags are. Basically, this is what's actually getting sent from the client to the server. Safe variables are all the variables of the character movement component. So what set move is going to do is respect component, and for us, it's going to look like this. Set variables are all the variables that you want in your character movement component. So what set move is going to do is it's going to look through all of the safe variables or all the variables that you want in your character movement component and set their respective saved variables. So it's essentially setting the save move for the current snapshot of the character movement component. And for us, it's going to look like this. So you can see we're first letting the super call its set move for, and then we're getting a reference to the character movement component, and all we're doing is setting the saved wants to sprint equal to the current value of the character movements wants to sprint. And it looks like we need to
Character movement request to sprint. I don't like this. This isn't the way that I want to do that, because it allows, actually no, I guess because you could be sprinting with aim down sights. In ours, maybe this does make sense after all. Because like in ours, I've got some other stuff that I want to do, right? Yeah, okay, I'll bite. I'll do it this way. I can get behind this.
include the definition for the character. That just added this header file so that we can call this function. Now, prep move is the exact opposite. So prep move is going to take the data in the saved move and apply it to the current state of the character movement component. So that's going to look like this. And you can see it's literally the same thing in reverse. We're just going to set the state data on the character movement component equal to the saved value in our saved move. And again, always remember, these saved moves, there's going to be an array of them, and we are potentially going to be running any one of these saved moves. And the server is also going to be running essentially a saved move. And so yeah, that does it for.
I will be right back. Aya is back. Ooh.
Save moves. Now we actually have to indicate to the character movement component that we're not going to use the default character move. We're going to use our custom save move. And the way we do that is through another class called the network prediction data client. And just like before, we're going to make our own custom version underscore zippy. And really, we don't need to do.
Good to know. All right, so let's get on that now. We've got one more to make.
Do much here. Again, like I said, all this is doing is indicating that we want to use our save move instead of the default one. And so all we really care about in this class is just this allocate new move, which will allocate a save move zippy. So let's implement these two methods.
Okay. That's not what I asked it to do, but it's cool that that's what it decided to do. And it's just like, oh, hey, we're going to do this in line. Even though that's not what you asked, we're going to do it in line. Oh, this is wrong here. I want it up here. So what's the issue here? Give me a moment. There we go. Beautiful. Okay.
And we don't actually need to do anything in the constructor other than make a call to super. And then in the just bring that up. And then in the allocate new move, instead of calling the default, we are going to allocate a new save move zippy. And if you're wondering why, usually you don't do any of this raw C++ stuff like heap allocations when you're using the Unreal Engine framework. And the reason why we're doing it here is because these two classes, the save move and the network prediction data for the client, these are not orienting from UObject. So you can see this does not originate from UObject. It's just a generic C++ class. And that means you can't do any of the nice casting stuff. So you can't upcast and downcast at will. And the reason why these aren't inheriting from UObject, if I had to guess, it's just because we want these to
all I heard is fuck pseudo. Interesting. Those are definitely words.
just be small because we're going to be allocating a lot of them and deleting them and whatnot. So we don't want to spend the time of allocating whole UObjects and deleting them on the fly because we just don't need that big framework of garbage collection and everything that UObject provides you. So that's why we need to do this kind of workaround of adding this second class. And so now we need to implement a couple of functions on the actual character movement component itself to indicate that we want to use this network prediction data. So that's going to look like this: get prediction data client, and
Wait.
indicate that we want to use this network prediction data. So that's
Wait. Give me a second here. Allocate move. Okay, so their allocate move is actually the same. So if I go to the allocate move, we want to have this not do this. We want to do F saved move pointer new FAG I want to change this. There we go.
Gonna look like this. Get prediction data client, and what we're gonna.
Okay, so get prediction. I now know how I'm going to do this. For the most part.
This now we need to implement a couple of functions on the actual character movement component itself to indicate that we want to use this network prediction data. So that's going to look like this. Get prediction data client. And
so where's the get prediction? Ah, they do have it. Okay, so here they've got it and it is public. So here we've got virtual F network road. Okay, and then we're going to, that's not what I wanted. We're going to replace it with our stuff.
What we're going to do here is we're just going to create a prediction data class that we just made. So this is a little bit confusing, but what we're doing here is we are checking if the client prediction data is a null pointer, and if it is, we're going to make it, but if it's not, we're just going to return what we already had. So this is a cached value of the client prediction data. So we're only going to actually create it if we haven't already created it. And so this is a const function because it's a getter essentially, right? But if the client prediction data is already null, we're going to have to make it, which means that we need a reference to the character movement component, which is non-const. So it's kind of an annoying workaround that there really is no better way to do it, but you're going to have to const cast away the character movement component reference, and then you're going to make a new network prediction data client on the heap and pass it in a reference to your current character movement component. And these are just two parameters on the client prediction data because, like I said before, the client prediction data does a lot more than just allocate, save, and move.
It's so bad. It's so bad. Okay, so check on owner equals is not equal to null. Null pointer. If not client prediction data, you AG character movement component mutable.
And so, yeah, these just alter how the networking corrections are handled. But so yeah, this is just one of those methods that you just implement and then just forget about because you shouldn't really need to touch this again. Now, going back to here, we need to create one more function to get all this working, which is update from compressed flags. So this is the final sort of step in the compressed flags, which is that now.
Okay, so then we've got update from compressed flags. Do
We are going to pass in a integer of compressed flags, and we're going to set the state of the character movement component based on those flags. So for us, that's going to look like this. So basically, all we're doing is we're just setting our safe wants to sprint equal to the value of the custom flag 0. So finally, that is all of the sort of infrastructure you need to now be creating and utilizing. It's going to look like this. So basically, all we're doing is we're just setting our safe wants to sprint equal to the value of the custom flag 0. So finally, that is.
what's the sprint? Wait, did he do that? Like, yeah, the not equal 0. It's interesting. So this would be request to start sprinting equals custom 0. I'm gonna move this over so I can have access to it easily. And we're going to do that.
safe wants to sprint equal to the value of the custom flag 0. So finally, that is all of the sort of infrastructure you need to now.
Now we have to go through and actually do a bunch of this stuff here, right? Because we've got a bunch of this that's not updated yet, right? Okay, so we've got clear. What's clear? There's some clear. We just want to have this. Reset all custom saved variables. Custom flags. And we've got get compressed flags, which we've already got this. This is the custom flag for that. Good, good, good. Set custom flag 0 to sprint. You use custom flag 0 to store sprinting. Then we've got can combine, which we need to do the combining stuff. Set which moves can be combined together. This will depend on flags used. Saved quest to sprint is not equal to new return false, else return super. That makes sense. Here we're just saying, hey, if this and the current one are not the same, then obviously we're making a change. They can't be combined. Set move 4. We can do super, and then we need a UAG character movement component. Character movement equals this is prep for, not what I wanted. I wanted this in here. There we go. There we go. And if character movement, there we go. That can be made const. Then we've got our prep, which is essentially the same thing, right? So we're going to do UAG character movement component. If character movement, and then it is nothing. We're not using that. Does this guy use it?
I'll be creating and utilizing movement safe variables. And does a lot more than just allocate the safe. You know, each flag kind of stands for some Boolean value.
There's clear set move. There's his compressed thing. Yeah, that makes sense. Prep for move, we're not doing anything? No, prep for move, we are doing something. Interesting. Okay, so in the gas shooter, they're not prepping anything in the they're not doing anything different in the prep for move. But in here, he's doing the safe move. Sorry, safe. Huh. I'll come back to that because we might not need to do this because they're not doing it here, and sprint does work over here in this person's project, right? So I guess we'll see.
In our save move. And again, always remember, these save moves, there's going to be an array of them, and we are potentially going to be running any one of these save moves, and the server is also going to be running essentially a save move. And so yeah, that does it for save moves. Now we actually have to indicate to the character movement component that we're not going to use the default character move, we're going to use our custom save move. And the way we do that is because these two classes, the save, you need to do anything in the constructor other than make a call to super. Save move and the network prediction data for the client, these are not orienting from UObject. So you can see this is not originating from UObject. It's just because we want these to just be small. That big framework of garbage, we want to use this network prediction data. So that's going to look like this, get prediction data client. You have to make it in a reference to your current character movement component. And these are just two parameters on the client prediction data. Now, going back to here, we need to create one more function to get all this working, which is update from compressed flags. So this is the final sort of step in the compressed flags, which is that.
Wait, that can be protected? If we do the super, update compressed flags. It's supposed to be protected. Wait, is this one supposed to be... sorry. Okay, yeah, it's supposed to be...
Now we are going to pass in a integer of compressed flags, and we're going to set the state of the character movement component based on those flags. So for us, that's going to look like this. So finally, we're just setting our safe wants to sprint infrastructure you need to now be open. You will read off the current value of get compressed send sprint, a saved move, and it'll use set move for to read off the current value of wants to sprint, and it'll save that into our saved wants to sprint. Then it will call can combine move with and see if there's any pending moves that are going to be sent to the server that are identical to the move we just executed, and it'll combine them if necessary. Then it will call get compressed flags, and it'll reduce the save move into this small networkable packet that it can send to the server. Then, when the server receives the move, it will call update from compressed flags, and it will take those compressed flags we just sent it and update the state variables, such as wants to sprint, from the client's movement data, and then it will perform the move that the client performed. And with all of this in place, those two moves should be identical. So now we have a movement state variable that is already automatically replicated from the client to the server, and it's completely movement safe. So if there's any server updates and the client has to update their position, everything will be in sync. We shouldn't have any rubber banding or hitches or bugs in our movement code. So now let's actually utilize this variable in some movement logic. So the first.
Okay, so let's actually do the one in specific that he did that we didn't do. Which I think was prep move 4. Yeah, here we go. What was his? Prep move 4. That's what it was. Save. Yeah, he wants to go the other way around. Essentially this, but we're going to reverse it. This here. Right? Hmm. Wait, what? Oh, that's why. So this can now be a Boolean. I died. Be right back. All right, I'll see you in a couple then. Lucifer. Lucifer died? No, we can't have that. Not allowed. Okay, so we've got that. Oops.
Is because these two classes, the save move and the network prediction data for the client, these are not orienting from U objects. So you can see this does not originate from U object. It's just a generic C++ class, and that means you can't do any of the nice casting stuff. So you can't upcast and downcast at will. And the reason why these aren't inheriting from U object, if I had to guess, it's just because we want these to just be small because we're going to be allocating a lot of them and deleting them and whatnot. So we don't want to spend the time of allocating whole U objects and deleting them on the fly because we just don't need that big framework of garbage collection and everything that U object provides you. So that's why we need to do this kind of workaround of adding this second class. And so now we need to implement a couple of functions on the actual character movement itself in our movement code. So now let's actually utilize this variable in some movement logic. So the first thing we're going to do is we're going to create two functions down here called sprint pressed and sprint released. And all these are going to do is simply toggle the safe move flag. And if you're paying attention, you might have realized, wait a minute, safe wants to sprint is a safe movement variable. But we just created this blueprint callable sprint pressed, which is obviously going to be called in a non-safe context in the movement component. So how is this possible? Won't this break the properties of movement safety? And the key here is that you can only call these functions on the client. So it's kind of confusing, but you can alter movement safe variables in non-safe movement functions on the client. You can never utilize non-movement safe variables in a movement safe function. And you can't call non-movement safe functions that alter movement safe variables on the server. So don't worry if that doesn't make sense because you'll build up more of an intuition when we actually start using this stuff more. But yeah, that is kind of the rule of thumb for movement safe variables. So now we have a variable that is completely movement safe, and the client can toggle the value of this variable by calling sprint pressed and sprint released. But it doesn't do anything yet, so let's create the logic for that. And we're going to do that in this function on movement updated. So this is a handy function that is automatically called at the end of every perform move, and it allows you to write some movement logic that runs regardless of what movement mode you're in. And the other thing we're going to do is create two more variables, and these will be parameters that you can edit in blueprints, and they're going to be called sprint max walk speed and walk max walk speed. And so these will determine how fast the character goes when they're sprinting and how fast they go when they're walking. So now if we implement this, and we're going to do this. So what this function does is it checks, okay, if we're in the walking movement mode, and then if safe wants to sprint is true, then set the max walk speed to sprint max walk speed. Otherwise, set the max walk speed to walk max walk speed. And this variable is going to automatically be used by the walking movement mode to basically determine how fast the player can go. And yeah, we're kind of piggybacking off of the walking movement mode for now. So, this certainly isn't a custom movement mode. I don't think sprinting is a mechanic that requires a custom movement mode. But yeah, this is it. This is how hard it is to make sprinting. And it, after all that.
This makes sense. So this would just be essentially I just need to do this, right? Movement mode thing. What was it? Sprint pressed, sprint released, right? So it would be a U function blueprint callable. I don't know if I want to make these blueprint callables, but it's fine. void set sprinting. Set request to start sprinter. There we go. Then in get max speed, we say if movement mode equals move walking, and request to start sprinting. There. I don't think that we need to do some of the extra stuff that he needs. Like the stuff that some of the extra stuff that he suggested. I don't think that we really need that. So. Oh, I forgot to make some changes here. Oh, I don't have my movement component that I wanted. Task. No, that's the I want this task. Here, this is what I need to fix because I don't actually want some of this, right? Uh, Can I cast this? Let's see if this is this castable? It is not. Okay. Welcome back. was it? It was new movement mode. None of these are quite what I wanted. Specifically, we just want the custom one. Move custom. I will be right back. I am back. Ow, ow. Always shocking myself. Let's see if this works. Wait, cancel. Save all. Now, this should just work. If everything went right, this should just work. Now for the real question. Huh, it works. Okay, so what we're gonna do is we're gonna delete all of this, delete this, here, delete this. I still actually want this to be like this, right? Let's see if this works now. Yeah, it does work. Okay, so it works. This needs to be a branch. This needs to be a rollback. Cancel ability. And then end ability. There should be cancel. There we go. There we go. I actually kind of want it to be a custom movement mode, but
So these will determine how fast the character goes when they're sprinting and how fast they go when they're walking. So now if we implement this, and we're going to do this. So what this function does is it checks, okay, if we're in the walking movement mode, and then if safe wants to sprint is true, then set the max walk speed to sprint max walk speed. Otherwise, set the max walk speed to walk max walk speed. And this variable is going to automatically be used by the walking movement mode to basically determine how fast the player can go. And yeah, we're kind of piggybacking off of the walking movement mode for now. So, this certainly isn't a custom movement mode. I don't think sprinting is a mechanic that requires a custom movement mode. But yeah, this is it. This is how hard it is to make sprinting. And it, after all that setup, it really isn't a big deal. It's really pretty easy. And you're going to be reusing the setup for everything else you do in the movement mode. So don't look at it like this is how long it took you to make sprinting. Look at it like this is how long it took you to make sprinting, because you're going to be reusing all this code for any other movement mechanics in the game. So now let's set up the character to work with our new movement component. So we're going to hop into the character class. And the first thing we're going to do is just add a variable that is our new movement component. that's going to be this guy. And I'm making him protected because he's going to be blueprint read-only. That way we can call those sprint pressed and sprint release functions from blueprints. And then the other thing we need to do is we're going to change the default constructor. So we're going to add this new constructor called that takes in an object initializer, and this will allow us to redefine the character movement component that we're going to be using. So if I hop into
We
the
don't
C++,
have to do this. We've already
we're going
done
to change
this.
this. And you don't have to exactly know how this works. It's kind of just Unreal Engine syntax, but basically we're setting the default subobject for the character movement component to be our own character movement component. And then lastly, all we need to do here is set the, we're going to cast the.
So we could do this, but we don't need to cache a version of something that we already have. Like casting is not that expensive in C++. And unless we're using it all the time, I don't see the need of having that extra memory be used.
Character movement to our new character movement class and store that in the variable we just created. That way we have a reference to our new character movement component, and we're going to include that definition up here. All right, so with this all set up in the C++ code, let's hop into the editor and let's link the blueprints to call those two functions and test out if everything works.
Okay, so here we go. This is what we care about.
All right, welcome back to the 5th video now in our series where we're covering Unreal Engine's character movement component in depth. So in this video, we're going to be covering sliding. In the last video, we did crouching, so it makes sense that now we're going to be doing.
Wait, isn't crouching already a movement
All
component?
right, welcome back everyone to this series where I'm going to be covering the character movement component in depth. In this video, we're going to be covering crouching and how to implement it in your custom CMC. Now, crouching is actually a feature that's already built into the character movement component, so we're just going to show you how to expose this feature and use it in your project. And I'm also going to show you how to make the camera transition smoothly because, as we'll see, the default character movement component does not transition the camera at all. So let's get into it. So how exactly is crouching built into the default character movement component? Well, to find this out, let's explore the getCompressedFlags function. And specifically, let's explore this flags enum. So if you can see here, there was these flags from last time that we talked about. And these were all reserved by the engine, and these are the ones we're allowed to use. And one of them you'll see here is wants to crouch. So as you probably figured out, we are going to want to change this flag, and this will automatically be replicated to the server, and the crouching will be all synced up. And the character movement component automatically handles the actual implementation of what this flag means to the actual capsule. So we can't just directly set this, however, because the engine actually handles this. So if we go back to here, we can see if we look at the super call is actually already setting the crouch flag right here from whether or not this wants to crouch variable is true. So we actually want to change this variable, and then the flag will automatically be set, it'll automatically be read, and the crouching will automatically be implemented. So let's do that. Let's go back to here and create a function. Let's create a function called crouchPressed. So there's two sort of ways you can handle crouching. There's toggle crouch and hold. So toggle crouch means that every time you press the crouch button, you will change states from either crouching or standing. Hold means that as long as you're holding the crouch button, you'll be in crouch. As soon as you let go, you'll be standing again. I'm going to choose toggle crouching, but you can do it whichever way you'd like, and the implementation should be only slightly different. And the reason why I'm choosing toggle is because later down the line, I want to implement sliding, and so it's going to be easier to use toggle crouch for that. So let's implement this function. And we're going to put it here in the input section. I did this a little bit off camera last time. If you're following along with the series, I organized all of our functions into these regions, and this just makes it easier to sort of store away the code and section up into manageable chunks. So here in the input section, we're going to put the definition for crouch pressed, and that's going to look like this. So really simple, just changing the value of b wants to crouch, and it literally just is a toggle. So this is where the name toggle crouch basically comes from, because you're literally just toggling the variable. And yeah, constructor. So this is just an annoying hiccup that you could find. So anyway, let's jump into the editor and make sure it's all crouch equals true. If you don't change this, you won't be able to crouch. So this is just an annoying hiccup that you could find. So anyway, let's jump into where we are in the editor, and all we have to do is some super simple setup on our actual character blueprint class to enable this to work. So if you'll recall, we made that variable on our zippy character movement component called crouchPressed. So now let's just get the C key, and again, just sort of setting this up, not necessarily the best way, but mostly for demonstration, sort of like the sprint, and we're going to call the crouchPressed function. And yeah, that's pretty much it. Before we actually run this, I'm going to point out, if we go to check out our crouch variables, you can see there's a couple of variables here we can set. So we can change the half height of the capsule when we crouch, and we can change the walk speed, and we can also tell the CMC whether we want to walk off ledges when we're crouching. And here was that variable as we saw before in the constructor that we set, which is just making sure that this is on, otherwise you can't crouch. So let's transition to uncrouch. So there's many ways we could go about fixing this. So capsule immediately goes down, and this isn't necessarily what we want. We like the player to actually smoothly transition into a crouch state and then transition into uncrouch. So there's many ways we could go about fixing this. The first thing you could do is you could actually, slowly transition the capsule to be, from this height to this height. And I'm not going to do that way. There's a number of reasons. One, because I'm just going to use the default setup for crouching in. Okay, so here in the code, I'm going to right click and I'm going to add an Unreal class. And unfortunately, there's no template for this, but we'll just start with UObject. We'll call this Zippy Camera Manager. Technically, I should have called it Zippy Player Camera Manager, but just to make the name a bit shorter, we'll just do this. And let's put in the correct template here. That looks like this, and the correct body, like such. And I just included a couple headers that we're going to find useful when we're actually implementing the blend. So All right, so the first thing we're going to do is create two variables, and these are going to be the crouch blend duration and crouch blend time. And my implementation is going to be pretty simple. Basically, we have a blend duration.
Okay, I see what he's doing here. This is just the player camera manager. I don't really care about that. We'll come back to that. We want to do this one.
Sliding, and sliding is also going to be our first custom movement mode. So if you're looking to know more about custom movement modes, maybe make your own, then this will give you a lot of good general information on how to make a custom movement mode, how to fit that into the system of the default character movement component in your own custom movement component, and this will definitely just help you understand the CMC a lot more. So before we get into it, I'm going to explain sort of how I'm going to implement sliding at a high level. So if here's our character, right, in the last video, we made it so they can crouch, and that just changes the capsule height, and then they walk slowly. So for sliding, you could do it a lot of ways, but I'm going to make it so that when the player double taps C, so the first tap makes them crouch. If they double tap, then they go into a slide where they go into a crouched height, but then they slide along the ground. And after a short duration, they pop up. And I'm also going to do it physics-based. So like if you slide on a slope, you will continue to gain speed and until you slide all the way on the flat part with a lot of speed, and then you'll pop back up once you slow down. So I'm not doing this with a timer. So like the time you slide or the distance you slide are not fixed. It's all about velocity. It's all physics-based. So when you slide, you'll get a short boost and you'll have friction as you're sliding. And then when you slow down to a certain minimum speed, you'll exit the slide. So this means you could technically slide like indefinitely on a long hill. And then the only other requirement other than speed for being in a slide is having a contact surface. So if you're sliding, say you enter a slide here, if you go off the edge, you're gonna pop back up and then just fall on the ground. And you're also going to increase your speed proportional to the slope that you're on. So steep slope, you're going to go really fast. If you try to slide maybe up a slope, say, you're not going to make it very far at all. So yeah, we're going to do it physics and velocity based. Not only is this easier, I think, and a lot cleaner with the code, but I think it makes for more interesting movement anyway. I think this is what most people are after, is this physics-based, momentum-based sliding. So that's what we're going to implement here. So let's get into the code. All right, so the first thing I'm going to do is do a little bit of setup to prep the character movement component before we jump into the slide implementation. So since this is our first ever movement mode, the first thing I'm going to do is add the custom movement mode enum. So this is going to be our personal enum that we use to keep track of our custom movement modes and switch between different movement modes. And you can see I put in here the first ever one, which is slide. And these are just kind of boilerplate for Unreal Engine. This is just kind of how you define an Unreal Engine enum with their syntax. But this is all we care about. And you'll see later on, we'll see what the default movement mode enum looks like. And I'm trying to stick to that format as close as possible. Next, we're going to make a cached reference to our zippy character. This I should have probably done like last video or a couple videos ago. I do this pretty much. I would always do this in a character movement component no matter what. It's just a reference to the character owner, and you'll see that this is sort of just the format that the character movement component wants you to do it, and this is how they do it, so I'm just going to follow them and get a nice reference to our character. And to make this work, we're going to have to set this value. So to do that, I'm going to do that in the initialize component method. So we're going to put that in here, and then for the definition, all we're going to do is just set the zippy character owner to the owner. And then we're going to make one more helper function. Down here, this will be a public function, and this is just going to be is custom movement mode. So this is going to be a function we call to check if we're in a custom movement mode. So that's going to look like this. Also really simple. We're just checking if we're in a custom movement mode and if that custom movement mode is the one we're checking against. Now we can get...
Okay, so let's go back to this person's code here. Because I think they actually did a... No, they didn't. They just did a wants to sprint and stuff like that, right? Like they're just these. I want a full-on custom movement mode for sprinting.
Get into the implementation of our slide. And to do that, we're going to define these four functions. This is our kind of miniature slide system. It's pretty straightforward. We can enter the slide, we can exit the slide. This function is in charge of the iterations, the actual slide mechanics, sort of. And then this is just a helper function to assist these functions. It just gets the surface that we're currently sliding on. So these three functions here are our own functions. I just use these to sort of assist the slide mechanic. This function, the fizz function, if you watch my architecture video, then you'll know about fizz functions. I recommend you should check that out to make sure you kind of understand what I'm doing here. But this fizz function is the actual part of the system that is required for every movement mode. So every movement mode needs a physics function to define how that movement mode behaves. And for us, that's going to be, typically it's fizz, and then the name of your movement mode, so fizz slide. And then it always has to take in this delta time and these iterations. So we're actually going to start implementing these from the bottom up, unintuitively as that may sound. So get slide surface. It's a pretty simple function. It's basically just a wrapper for a line trace. So we're going to just define, we're going to start the line trace at the component's location, kind of the center of the component. Then we're going to end at 2 times the half height down. So this is the line we're creating. And then we're just going to do that line trace and just return the result because it already returns a boolean anyway. Also, you might have noticed this guy. I think I did this off camera between this episode and last.
Oh, right. I wanted to do something else in my task here. I'll do that. True. Beautiful. Okay. So this would be I want here, I need one more. There. Actually, wait. I should probably do this here. Like, essentially this. No, because this is actually something we want. Is jetpacking not a word? Okay, it is a word. Oh, it's two words. That's why. Huh. So it would be jet packing. Then we can remove that. Don't need. We can come down here. Sorry, we can come down here and remove that. Don't need that. Boom. There. This is E custom movement mode. E custom movement mode. Which I totally probably spelt wrong. Don't need to do that twice. Here we go. If new movement mode is equal to move custom is not equal to return. New custom movement mode. To do. This is difficult. Okay, so essentially we just want to do changes here. We want to do AG movement mode and components set movement mode equal to there. Then if we come over to movement component, we want to do set movement mode. That's not what I wanted. God damn it. Jump to here. There it is. And this is public if I'm not mistaken. Yeah, okay. So under public, we do virtual fuck. Set movement mode. Yeah, okay, so we can virtual void set movement mode. And then we're going to generate the definition. And we want this, and then we want which switch new custom mode. But we want to use new custom mode as that's not really what I want here. I've got a thing for the get max speed, right? Get max speed. Oh, that's not really what I want. E E custom movement. Okay. Oh yeah, we're moving to Unreal 5 at some point. Okay, so uh treat. Actually, let's see how he does his first.
This is a function I'm calling on the zippy character owner that I made. I like to make this ignores the character and all its children. So if you don't know about like collision checking and you don't know about the query params and ignoring actors, don't worry about this. But the character and all its children. It's a nice little helper. Also, you might have noticed this guy. I think I did this off camera between this episode and last. But this is a function I'm calling on the zippy character owner that I made. I like to make this for every character I make. It's just a nice little helper function called get ignore character params. So anytime I'm doing like a geometry collision test, I can call this helper function that will just create a collision query params variable that automatically ignores the character and all its children. So if you don't know about like collision checking and you don't know about the query params and ignoring actors, don't worry about this. But you should have this. This just makes sure that the line trace doesn't hit
This is actually really good.
the character because you can't slide on yourself. You want to ignore the character when you're performing the line trace. So before I implement fizz slide, I'm going to define a couple parameters that will characterize how our slide. What is the amount in the place? I'm going to here. We're just making sure that the delta time we're given is
Okay, so let's go to here. Yeah. I want to use a u int 8 as if it was an. Actually, wait. U int 8. Right? give me a moment here. This is a U int 8, isn't it? Oh no, it's not. Damn. I want to treat a or was it a blueprint enum. Blueprint type enum. I want to treat a blue type enum as if it was a u int 8. Sorry, I want to oops, want to treat a u int 8 as if it was a I might need the class. There we go. The only thing that it can be is a uint 8, right? So this works perfectly. And then we come over to our character movement component and get rid of these. They don't matter. And come down here, and then when we do this here call, we should be able to do a e custom. We do this cast static cast e custom movement mode e custom movement mode. Now we do this. They've got all of this, but like we want the this needs to be set first, and then we'll change it down here. Why is this being weird though? How is it unreachable? E custom move. How would this not be able to be done? Like, this should just work, right? Like, how is this unreachable? So this actually needs to be an if. Uh, do, 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 do. Really, the ideal way of doing this would be having a custom movement mode, and then we flag the new custom movement mode as, say, sprinting, right? Error use. New movement mode is not available. Wait. If has handle change. Oh. Wait a second. Why would this set... This is just rude. Oh, wait. If new custom mode is not equal to 0. My bad. So I want to do this. This is probably what I want here. Oh, wait. Do, 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 do. That's supposed to be a value of 1. What the fuck? Oh wait. Unsigned char? That's not supposed to be an unsigned char. So it's all gonna revolve around the physics update shit. It still stepped over it. This should be working. Like this should just work. Why this doesn't work is something I don't understand. What if we do I don't actually care about the fuck's sakes. So I can't have. Okay, how is this guy doing this?
is not less than the min tick time. This is mean time greater than the min. Motion is essentially never defined to. We have so if we are traveling under the slides and efficient, and then for same exact frames or in a safe, it's only gonna right on. I'll leave that. All right, is this movie is from the caption velocity system did something with like sliding works, is there just gonna and with these two functions now. Basically, when we enter a slide, we're going to set wants to and then walking, falling. So flying and custom is not currently connected to the system. We're gonna connect it. All right. So the first thing we're gonna do is define a new save move variable. Actually, our first save move variable that's not a flag. So this is a save move flag, and this is going to be put into the compressed flags. This is not going to be a flag. This is not going to be replicated at all, but it's important to the state of the movement logic. It's important to what gets executed, so we do want it to be saved, and that is going to be prev wants to crouch, or just the previous value of wants to crouch. And yeah, basically we're just storing the previous value of a flag, so not a big jump, but we're just storing the previous value. The reason we're doing that is because we want to get this edge detection where we detect a new variable to detect this event when we have how this move will be performed. So to make this save variable sort of synced up, updated. So here we're going to add, then you'll know for every save variable, we need a save variable in the character. This is not in the character move component. This is in the save move. To make that clear, we need, this variable, prev wants to sprint with a safe prefix. This is the working variable. We're going to use this variable in our logic, in our actual character movement component logic. It's going to be stored in this saved variable so that if we want to replay a move at a later time, we need to recreate the state that was able to produce that move. So we need to save this variable because it's important to the state of how this move will be performed. So to make this save variable sort of synced up, we're going to have to add it to our set and prep functions. So here we're going to add this line, kind of just following the general syntax. We're just storing the save value from the character's save value. And the opposite right here, we are putting the save value back into the character's save value. So setting and prepping the moves. If you aren't familiar with what this is doing and you do want to know, because it is definitely important to how the character movement component operates, check out my introduction video where I set up the character movement component and implement sprinting. The next frame. Next, we are going to implement a function on the character movement component called update character state before move. Now this is going to be where we do the edge detection and where we can enter the slide movement mode. The two updates I need to, and they.
Okay, so wait. Okay, so this doesn't work the way that I want it to. I just want to be able to compare, but apparently you can't. Or new custom mode is equal to 1. Can I do an evaluate? Where's my evaluate? Wait, where am I? Fucking don't want that. I'm okay with it not allowing me to move forward. And then I'm just going to go look for custom movement stuff to wire up custom movement components, because like the rocket is going to be a custom movement component that we want to move forward with at some point, right? Cool. Cool. So what we want to do is just do this, apparently. And then we'll just redo this. What the? It skips over it. It straight up just skips over this completely. It's just like, hey, skip to set move. I don't care about anything before it. Is this being like, is this supposed to be like being like trace? Sorry, screen debug F color cyan new custom mode. Let's just see if the... Okay, so... we go from here straight to here, skip over all of this. Right? Like... request to sprint, false. It's being set to true! I'll be right back. Oof. Back. I wonder if I move this up. I almost want to take this and move it, but I also don't like the idea of changing this. I guess maybe I should do the on movement changed. Let's try this. We're just gonna skip over it. Completely skip it. Just be like, don't even worry about it. Like we're definitely gonna be stopping, right? Because the physics thing doesn't work with custom movement modes. Like we have no physics controller for it essentially, right? Did we skip over it yet again? Like it's just like it's skipping over everything that I care about. Yeah, look, it skipped over it. It fucking skipped over it for some stupid reason. I don't. Well, maybe not this time. Nope, skipped over it. Okay, let's try this again. To do. So we want to evaluate a custom movement mode is equal to custom move sprinting. True. Okay, so if we go to this, request to start sprinting is false. Okay, so what is this? Result is 1. I feel like this is getting optimized out for some reason. So we're at 129. We step into it. We jump immediately down to here, right? This is fine. This is supposed to be false. Come over to here. We hit sprint once, right? This should be not false in this situation, right? So if we do custom movement mode, no, custom. Is 1. Is it equal to 1? True, right? So where are we at right now? We're at 129, right? We step into and it immediately jumps over. So when we look at our request to start sprinting, it stays false. Because reasons, right? So if we step into this is a bunch of stuff that, while it's relevant, is not really what we want, right? General Kenobi, why is that redundant code? I'm not sure. I am like legitimately unsure as to why it's doing this. Also, welcome back. It's been a while. Yeah, I'm unsure. I've got to do some research, so I've been at this for about 3.5 hours, so I think I'm gonna call it for a while and then what song? All right, I might be back a bit later. I might just take a break. I haven't been feeling well all day, so I just wanted to do something that would like clear my head a little bit. So, anyways, I will catch you all later. Thank you to everybody who showed up and chatted and whatnot. We'll see you later. Ta ta for now.